Alright, so we've already discussed angular average velocity and angular average acceleration. But I'm going to go back and a quick reminder that in calculus-based physics, we have the ability to find easily the velocity or acceleration at one particular moment. And we do that by decreasing delta t, because remember the delta t is on the bottom, so the smaller we make delta t, the more likely we are to have it at one particular moment, where the difference between the two times is like 0.0001 seconds. That's essentially at one particular moment in the motion of the object. And when we take delta t down to 0, that's essentially the same thing as taking a derivative. So if we want to find angular velocity at one particular moment, we need to take the first derivative of the position function, so angular position this time, and that gives us a function then that we can plug our time value in and figure out what the angular velocity is at that particular moment. We can do the same thing between angular velocity and angular acceleration, where if we're given an angular velocity function, we can take the first derivative and find a function for the angular acceleration, which then if you're given a time, you can plug the time into to find the angular acceleration at that particular moment. Additionally, if you are given the position function, so angular position function, you could take the second derivative and that will also give you a function to find the angular acceleration at one particular moment.